Good afternoon, or good evening, or good morning, depending on when you're watching this video. Right now it's good morning for me. Welcome to Coach O's Math, Pre-Algebra, and today we're going to talk about problem solving using real numbers. Now in the book it talks about integers, but we've learned that integers are a subset of real numbers. And on the types of equations we're going to be solving, you can get fractions, so you got to get used to working with those. So we're just going to use all real numbers, with an emphasis on negative numbers. So the one thing we want to remember, that when we're solving equations and isolating the variable, we use inverse operations. So now when I read this, remember that the signs have dual roles, depending where they are. This one right now, the plus sign is used as an addition sign as we read it. Negative 14 plus x equals negative 20. However, if I just looked at the x, and this is very important, if I just looked at the x, I would see that it had a positive 1 as a coefficient. This is a negative 14. So using inverse operations, since we are subtracting 14 from both sides, so when we look at it that way, we don't look at it as a negative, we look at it as, oh, we're subtracting 14. What's the inverse operation of subtracting 14? To add 14. So we add 14 to both sides. We don't say take the opposite of negative 14. We say take the inverse of subtracting 14, which is adding 14. That's going to be the hardest thing to do to get into the math lingo. So when we do that, this cancels, the x comes down, and we get negative 20 plus 14. So all that practice we did with positive and negative numbers of adding and subtracting, now we're going to use it. So negative 20 plus 14 is negative 6. You always do a quick check, and you plug in, you say negative 14 plus a negative 6 is indeed negative 20. So let's look at a couple of them that I did, because I want to point out, because this is pretty much going to be reviewed with the exception of now you're dealing with positive and negative numbers. So let's look at this. 4 equals 10 plus y. We're going to subtract 10 from both sides. Some of you are going to want to go and subtract the 4. But remember, you go to the side of the variable. You go to the side of the variable and you subtract 10 from both sides. When we do that, we get 4 minus 10, which is negative 6, equals y. You can write it like this, or you can rewrite it saying y equals negative 6. It doesn't matter. So when we go back and we plug in, mentally, 10 plus negative 6 is 4. Now this one I didn't work on purpose in advance. We're going to do this one together. Again, remember right now the variable's in the numerator, so we're going to multiply. We need a coefficient of positive 1 to solve for the variable, so we're going to multiply both sides by the reciprocal of the coefficient. Now the coefficient is 2/3, because if I pull that x out, which I can, then this becomes 2/3 x, which is the coefficient of x. So we're going to multiply by the reciprocal. This should be old hat to you now. And we do so, this is going to be x equals 6, right? Because 3 times 4 is 12, and 12 divided by 2 is 6. We go back and we check. If x equals 6, then 2 times 6 is 12, divided by 3 is indeed 4. This one's trickier. Still, the negative is in the denominator. This is the problem you're given. Really important to remember. This is the problem you're given, and the negative is in the denominator. Hold on to that thought about the negative being in the denominator. So we're still going to treat this because the variable is in the numerator. So the coefficient of x is negative 2/3. Now you may say, oh, Mrs. Cohen, it's negative 3. No, it's negative 2/3. So we're going to multiply both sides by a negative 3/2. Important, because our goal is to have a coefficient of positive 1 for x. So when we do that, these cancel. X comes down, and we now have negative 6. 4 times negative 3 is negative 12. Negative 12 divided by positive 2 is negative 6. We plug it in. 2 times negative 6 is negative 12. And a negative 12 divided by negative 3 is a positive 4. Now take a moment and let's go back and let's talk about that negative in the denominator. Let's solve this problem. Major mistake for many students. We're going to divide both sides by -4 because we're multiplying by -4, and we're going to use the inverse operation. Watch what happens. This cancels. Students, I'm going to come over here so it's easier for me to write. Students want to write this because we divided both sides by a negative. No! That's not done. Not done. You cannot leave a negative in the denominator. Never leave a negative in the denominator of a fraction. Why? Where do you put it on a number line? Because this says 3 over -4. Where would that go? You can't leave it like that. So, how do you move the negative? Because remember, in math, I could say, oh, you just pull it out front. But you have to have a reason why you pull it out front. You have to have a reason why you pull it out front. So, what is this? 3. It's a positive 3. So we have positive 3 over -4. A positive divided by a negative is a negative. That allows us to change it to x over -3/4. And you can pull the negative out front, and you don't have to show this. You just have to know it mathematically, that there is a reason why I can move this negative to the top. Okay, never leave a negative in the denominator. Never leave a negative in the denominator. Now, you can be given problems, hence, where there's a negative in the denominator, but that's the problem. It's not simplified or solved yet. Okay, what I want you to do now is I want you to try these, stop the video, do these problems, and I'll come back. Welcome back. Let's see how you did. Do a quick check. You should have for the first one x equals -3. For the second one, n equals 9. X equals -28. Remember when we're subtracting 14, because the inverse of adding 14 is subtracting 14, we have -16 minus 14. It's not -16 minus a -14, it's -16 minus 14. Whatever we do to both sides, we take that sign and we use it in our favor. Remember, it has dual roles. So here it's -16 minus 14, because this sign is a -14, but it's also subtracting 14. Here's the kicker. Let's see how you did. You add 8 to both sides. You bring down, remember this has a dual role. We're subtracting x, but when we take out and we cancel -8 plus 8, we're left with -x. Don't drop the negative sign. You have to bring the whole thing down, because now that subtraction sign is a negative sign. We get -x equals -30. Well, we have to add 8. We get -x equals -22. The coefficient of x is -1. Therefore, we always say you have to isolate the variable with a +1 coefficient. This is a -1. So how do you undo that? You manipulate. You don't have to add x to both sides now. You have the knowledge to say, oh, I can divide both sides by -1, or I can multiply both sides by -1, get the same result. If I multiply -1 times -x equals -22 times -1, I get x equals 22. So it doesn't matter. Now this one I want to work with you together. Well, first I want you to stop the video and I want you to do this problem. -14x equals 2. Let's see how you do. Okay, let's see. Alright, we're going to divide. Hopefully you see the inverse of multiplying by -14 is divide by -14. Here's the kicker. Why did I do this? Because I have a negative in the what? Denominator. So these cancel. X equals. You got to simplify this. If you leave it like this, you will lose a point. That's pretty severe, but it's pretty important that you never leave a negative in the denominator. So it becomes x equals -1/7. Why? Why? Why can I move the negative above into the numerator or pull it out front? Why can I do that? That's right, because this is a +1 over a -7, and a positive divided by a negative is a negative. All right, I want you to write down 2 things that you learned and 1 question you still might have about solving these types of equations with real numbers. And I'll see you in class.